In today's note, we are going to continue looking at expanding binomials, but we're going to be looking specifically at some area problems or some word problems. So again, if you need a refresher on expanding binomials or the FOIL method or the box method, please go back and look at the previous lesson because that is going to be important for this note. So in the first example, a college campus has a rectangular flower garden with the following dimensions. We can see it here, x minus 3 is 1, and 2x plus 6 is another. We want to write a simplified expression that describes the area of the flower garden. So because we're dealing with area, remember area is length times width. In terms of my flower garden, we can call this length and this width. Again, it doesn't really matter because when we're multiplying two terms, order doesn't matter. So we could switch this around, and again, I can rotate the rectangle a different way, and we could switch the length and the width, and it wouldn't really matter. So I'm going to replace my length and my width in my area formula by my two dimensions. So x minus 3 and 2x plus 6. And now we have to multiply these two binomials together. So we're going to use the FOIL method or the box method, again, whichever you prefer. But we should get 2x squared plus 6x minus 6x minus 18. And if we combine our like terms or our x's, we should get 2x squared minus 18 because our plus 6 and our minus 6 cancel each other out. So this is what we're left with. And that is our simplified expression that describes the area of the flower garden. I can't reduce it any further, or I can't simplify it any further, so it's our final answer. In the next example, we have the same idea, except we're dealing with a rectangular prism, or 3 dimensions, and we want to find the volume of the prism. So volume of a prism is length times width times height. So again, I can order, or I can rearrange or label any one of these dimensions as length, width, and height. Doesn't really matter. I'm going to replace the length and width and height in my volume formula with these dimensions. So I'll put x first, 2x plus 5, and x plus 3. Again, it doesn't really matter the order. I can't use my FOIL method yet, or I can actually if I want to just focus on these two binomials over here, but I like working from left to right, so I'm going to deal with my single term here, the x, and then multiply it or expand it into the first binomial. So in this case, I'll get 2x squared plus 5x. And now I can use my FOIL method to expand these two binomials. If you did it the other way, where you expanded the binomials first and then are going to multiply that x through to everything, that's fine as well. You should still get the same answer in the end. So again, going to use my FOIL method. So 2x squared times x is 2x cubed plus 6x squared plus 5x squared plus 15x. I'm going to combine my like terms. So in this case, 2x cubed plus 11x plus 11x squared. Don't forget the power. And 15x. I can't simplify anything further because these are not like terms, so they have to stay where they are. So this is my volume of the prism in terms of x. The next one, Jeff is putting carpet in 2 rooms of his house. The dimensions are shown in the figures. What is the total area to be carpeted? So basically, what is the total area that we need to put carpet in for? So we know how to find the area of these two shapes. We know the area is equal to length times width. So I'll find the area of the first one, or x times x plus 3. I'm not going to use FOIL, but I am going to use my distributive property. Same idea, x squared plus 3x, and that's the area of my first shape. the area of my second shape. I'm going to have x plus 5 times x minus 2. Here I can use my FOIL. And get x squared minus 2x plus 5x minus 10. I'm going to collect my like terms or my x values and get x squared plus 3x minus 10. So these are my two areas for my two rooms. To find the total area, I need to take the one area and add it with my second area. So my first area was x squared plus 3x. And my second area was plus x squared plus 3x and then the minus 10. So because it's addition between these two expressions, I can just write everything out as normal, keeping the signs the way they are. And now I'm going to collect like terms. So I have some x squareds, and I have x's, and the constant, then minus 10 is on its own. So when I add them together, 2x squared plus 6x minus 10. This is my final answer here. This is my total area when I've added both of my areas of the shapes together. So same idea as what we've been doing, except now we're just adding the two results and collecting like terms. The next example, a landscaping company is placing a pool into a client's backyard. They plan to cover the remaining area with grass. Using the dimensions below, determine the amount of grass needed. So a similar idea to what we were just looking at, except it's going to be a little bit different. I have two shapes here. I have my area of the pool, and I have my area of the grass. Based on the shapes, they're both rectangles, so it'll both be length times width. And I can see my dimensions. So first I'm going to do, if you're not sure what to do, because we're dealing with the amount of area needed, let's at least find the area for both shapes and start with that. So for the pool, we have x times x plus 3, distributive property, x squared plus 3x. If I look at the next one, we have 3x plus 2 and 2x minus 1. Here I'm going to use my FOIL method and get 6x squared minus 3x plus 4x minus 2. I'm going to collect my like terms, 6x squared plus 1x minus 2. So now I have my two areas. Sorry, I guess it won't be area of the grass, it'd be the area total because it's the entire shape. So I have the area of the entire shape, or the large rectangle, and I have the area of the pool. If I want to figure out the shaded area, or the green area, or the area of the grass, I need to be able to figure out, okay, how much is remaining of this large shape when I remove the pool. So what we're going to do here is we're going to do for the area of the grass, we're going to take our first area, or our total area, and subtract the area of the pool. So in this case, the total area is 6x squared plus 1x minus 2. And we're going to subtract the area of the pool. So this is going to be a little bit different. X squared plus 3x. So because we're subtracting, I'm going to put brackets around everything because we want to make sure that we're subtracting everything in that bracket. So 6x squared plus 1x minus 2 can stay the same, but we're going to minus the x squared and then minus 3x as well. So you could also think of this as an invisible imaginary minus 1, and you're going to distribute that through, so we get the minus x squared and minus 3x. Once that's done, we are going to collect our like terms. And we can see we have x squareds, we have x's, and the constant stays on its own. So doing this, we have 5x squared, and then our x's are minus 2x, and then minus 2. So therefore, the area of the grass is equal to 5x squared minus 2x minus 2. So that's the amount of grass that will be needed. In our final example, it's the exact same type of thing that we've looked at. We want to determine the area of the shaded figure. The same idea, except just more work is involved because now we have 3 figures. So I'm still going to try to figure out the total area of the entire large shape, which will be length times width, and we'll start with that. Again, if you know how to figure out the area of a shape by using the FOIL method, at least start with that. If you're unsure of what to do next, then you can kind of play around with those 2 answers, but find the areas first. So 7x minus 3 times 5x plus 6. I'm going to use my FOIL method. Get 35x squared plus 42x minus 15x minus 18. I'm going to collect my like terms. So 42 minus 15, so plus 27x, and then minus 18. So that's the total area. I'm going to find the area of my 2 shapes. We'll call it A1 and A2. So area 1 is going to again be length times width. We have 2x times 3x minus 4. I'm going to use the distributive property, 6x squared minus 8x. Area 2, same idea. It's a rectangle, so length times width is equal to x plus 8 times 2x plus 7. Again, use the distributive property. X times 2x is 2x squared. X times 7 is plus 7x plus 16x plus 8 times 7, 56. And I can collect some like terms here. I can collect my x values. So I get 23x plus 56. So I have my areas for all the shapes, but again, I want to find the area of the shaded figure. So in order to do that, I need to find how much is not shaded, and I can do that by adding the 2 together. So the area of unshaded, or US, is equal to area 1 plus area 2. So we have 6x squared minus 8x, and because it's adding, I can just throw in the others right after it. So 2x squared plus 23x plus 56. Now I'm going to go through and try to find all my like terms. So I have the x squareds, and I have the x squareds, and I have the x's. So when I combine all those together, I get 8x squared plus 15x plus 56. So that is the area of the unshaded part. So last but not least, I have everything I need to find the area of the shaded. It's going to be the total area minus the area of the unshaded part. So the area total was 35x squared plus 27x minus 18, which we had already figured out. And it's going to subtract, and when I'm subtracting, I'm going to use brackets. The unshaded, so 8x squared plus 15x plus 56. When we're dealing with subtraction, you can imagine that there's an imaginary 1 in front, so that it could be a -1, and you have to distribute that through. So 35x squared plus 27x minus 18 minus 8x squared minus 15x minus 56. And again, you're going to go through, find all your like terms. So I have x squareds that are similar. I have x's that are similar. And last but not least, I have constants that are similar. I'm going to collect all these like terms. So 27x squared plus 12x, and then -18 minus 56 gives me -74, and that is going to be the area of my shaded figure. So again, a lot of steps here, but it's all just focusing on the same idea of multiplying or expanding binomials. In some cases, you may have to add them together or subtract them depending on what the question's asking, and you do that just by collecting like terms after you've added or subtracted them. But again, make sure you're taking your time and go through the steps carefully. Look back to the previous note if you need to review expanding binomials.